once you are done with this demo, then you can go to that location. So we are showing some other applications. So this is more the demo of the connectivity and some data transfer. But what we see there is how we are processing the data. We are using the Amazon server to process our data, so it will show how quickly we are processing the data. And also we'll show some equipment that we are using for our connected autonomous vehicles. So right now, what you are seeing there, we have our centers connected cars. So we have 4 cars. We'll show the demo with these 4 cars. So all are equipped with a headnet. We mentioned about headnet. So anyone remember what headnet is? What? Heterogeneous, right. So what it means that we have a box and we have developed a software. What it can do, it can see that, okay, what application we are trying to run. So is it collision avoidance? So when 2 vehicles are getting close, it's sending a warning, or it is queue warning. So we might do both at the same time. So when a vehicle is stopped, it is doing a public service. So it is sending message to other vehicles 5 miles away that, okay, I'm stopped here and there's a congestion, there's a queue. And once people 5 miles away, 6 miles away, 10 miles away, 15 miles away know there is a queue, then they can take a divert, they can take another route. So now the 2 things I want to point out, the strength of what we are doing. So you might say, okay, my car has this sensor, collision avoidance, right? But your car, no matter how many sensors you have in the car, it cannot have a 360-degree view around it, right? So because the sensor may miss something that is in the corner. So what we are doing here, we have a 360-degree safety net around each vehicle. So it's just each vehicle is now when they're sitting, they are transmitting messages. Its location, speed, bumper height, anything. The brake status is transmitting 10 times per second. So the message is transmitted 10 times per second. So no matter if anyone is listening or not, like I do in the class, I don't care anyone is listening. Most of the time they don't listen, but I talk, right? Like a crazy person. So the car is transmitting, and any vehicle or device that has the same box, it can listen. It will know exactly what's going on. So when the car is stopped, the other car behind it will know right away, in less than 1 millisecond, that something is happened, the other car stopped. So we are using DSRC for that. But at the same time, when it stopped, it's transmitting message to other cars. But now, so you saw that okay, we have this sending message, okay, but then we are using LT. But how we know it's really a queue or not, right? So it might be just the car stopped because it slowed down, or but so we developed an artificial intelligence-based algorithm. So based on the data that it's receiving from the car, it can accurately tell whether it's a queue or not, the condition or not. So that is the one super development, that we can tell with very accurately that there is a queue or not. Otherwise, the vehicle may stop for anything else, right? So, but we are processing, and our system is learning over time. So when it makes a mistake, it goes to our server that, okay, my algorithm made a mistake, and it gets better over time. So, and we are, the way we are running the algorithm, it's in a distributed fashion. So we have several layers of analytics. So our machine learning, the algorithm is running in different layers. So, and what you'll see visually, that, okay, collision warning, when one vehicle stopped, you'll see that there's a warning. So each vehicle will see that. Okay, so but you are not on the in the vehicles, you'll see what the other vehicles are seeing. When it will stop, in an instant, less than 1 millisecond, it will see that there is a vehicle stop. Okay, and when it stopped, you'll see that the algorithm is now activated, that the algorithm detected that there is a queue. So this will be activated. Now this went through DSRC, this is through LTE. And we, if you have Wi-Fi, 5G, so it will know which one to choose. So that's really efficient. And so this 3 vehicles, you'll see they just stopped. So they got a collision avoidance. But the 4th vehicle, is far away, and with the data of the 3 vehicles, our algorithm detected there is a queue, so you'll get a queue warning attack. And also we have a on the web, on the cyberspace, we have the CV guard, which is monitoring if there is any bad, that red vehicle there. Okay, so it's monitoring that. Whenever it detects there is an attack, it will activate, there is a attack. So, and it knows all the tricks I mentioned, that okay, it will try to identify what vehicle is that and separate that, and but the first thing it will detect there is a cyber attack. So we'll show these applications, and also we use to test when we send it through LT, so we have to get service, but we have our own LT station for testing. When you go to there, you'll see our LT station and how we are analyzing the data in Amazon server. So we'll see that, but first we'll see, and this is so this is to show you. Now we have a test bed. We do testing on perimeter road, right? So we constantly do the testing on perimeter road, but right now we are just showing, this is the location here, so we are showing here, but most of our tests are done in perimeter road, because we have an interaction with the signal controller, so we can know when the signal will turn green, red, and yellow, and we advance according to that. And one important thing, yes, please.
So my question is, can you take your system here and could you bring it to Greenville
Of course.
CUI card and begin to demonstrate
Anytime. Yes, it's ready. So it's ready. Yeah. So another thing that we did. So you know the Michigan test bed, they had the first, but what? So they share data, but most the historical data. But if you want to use our test bed, you want to see what's going on in the real life. We have an web interface, so you can access our test site on Perimeter Road from Charleston, from California. So you can see. So when we are doing the testing, we'll get the real-time data instantly that what's going on. And if you want to request, okay, I want you to test this for me, like some application, eco driving with signals. So we can actually set up the test and we can run it here, and you can get real-time data. So we also developed this real-time toolkit. So anyone like Citadel, if you want to do a pedestrian vehicle study, anything, you can use our test bed. So it was developed as a part of our UTC project. So we'll show the test that how we use our that toolkit that we developed. So it's much better than what Michigan has. Michigan, they are not very good in sharing the real-time data, but ours is. So now,
Question.
yes.
What % of your technology is off-shelf and what % is proprietary?
That's a very good question. Excellent. So the device that we are using, so for DSRC, is a commercial product. So we purchased that, and then we are using LT. We can use telephone service or our own LT station. So that's also, we can say, commercial. So, but the software that we developed to choose the communication options, HETNET, that is our product. But the devices are we purchased. So where are our drivers?
No, sir.
Taking one of these and passing it. But Wayne did bring the purple car, so we see it.
Yeah. So and one attraction. So I think. So I would like to. I think one important demo is Wayne's car. So this is the car that we simulated in our autonomous vehicle.
I do not contribute anything to roadway taxes.
Right.
It is totally electric.
Right.
On top of it, I charge it for free on campus.
Right. But yeah. So if it hits a pedestrian, it will be destroyed, right?
Yeah, it's not the.
So we have these 4 drivers. So as you can see that when that car stopped, the collision avoidance message, and this is the middle is the speed profile. So you can get all, that is used in the algorithm too, the speed profile. See, it got stopped. If you can see this,
Yes.
and just the message was transferred. So yeah, you can. You want to talk? Okay, so you'll see. So it is. We are receiving it through DSRC, and the Q warning, because it's going to a roadside device. So we have a roadside device that is receiving the message, and the roadside device is sending that to the farthest vehicle through LTE. So this is a headnet application going on at the same time. So they are starting. Okay. So you can see. So it's activating the. It's not close enough, the other one is getting close. So you see that how quickly it's just within a very short, and then so the collision avoidance, and now it will go through two medium. So where is the DSRC unit? Okay, so it's transmitting here, and then Q warning is going, first is coming here, and then with LT it's going to the fourth vehicle. So yeah, so that's the KT is the vehicle. So that's the last vehicle that is receiving the data.
So I just create a attack from here.
Okay, so do you want to add anything to it, or?
So if they are forming here a queue, and from the card 3, I have the controller of the card 3 here. So if any cyber attacker in card 3 want to create any problem in the network.
Okay, so but do you have any comment on this one or no?
Yeah, I think
Okay, all right.
So this is I am logged into the card 3. So card 3 will try to break down the whole network, and our
So
infrastructure.
denial of service, so it will send fake data, so useless information like my class notes. So.
And you see from there, so we can, from the network side, we can see that the card 3 is creating an attack. And
So it detected our CV guard detected that card 3. Now we'll play with the CV guard. So we need to know more about it, right? So
yeah. So the thing is that when the card 3 is attacking the other vehicle, so the data from the other vehicle is getting a high latency. So it is getting the
delay, high delay.
High delay. So the data that is coming from the car to the infrastructure is having a high delay, and this will create problem to the other applications.
Like we saw in safety application, then it will not work. So there are like many safety applications that we can run with connected vehicles, but those will not work when this RSU is not working. We're just breaking down this. This is the roadside unit. So this is we purchased this. So there are several companies which make this type of devices. So it can cost anywhere between $1,500 to $3,000. So this device, this is a roadside device, and we have also devices in the car. So after we do one more demo, and then I will show you what the onboard units in the car. So you can.
Where is that roadside device? Can we see it from here?
It's
Is it on the side of the road?
Oh, it's here. This is the roadside device.
Right there,
Yes.
in that computer.
Right. So
Oh,
sorry.
there, okay.
This-
Yeah.
So,
I understand.
so yeah, it's transmitting at a frequency 5.7 to 5.11.
So it could be permanently located at
It will
an
be. It will be
intersection or
permanently
something like
located.
that.
It will be. Yes.
And that's what costs $1,500 to $3,000.
Right. But the cost is going down. So yeah.
Who makes that? What
So there are several companies: Cisco, Arada, then
Nvidia.
Coda. Yeah. So this is a Coda product.
Coda.
Coda.
Ronnie, what is the range of the
So the range is about 700 feet. So that's why 5G. So that's why we have to use LT to send to a farther distance with beyond 700 feet. But LT has a higher delay, so you cannot use it for safety application. So that is why we have to use HeadNet.
HeadNet, is HeadNet something you invented?
Yes,
You are.
yeah,
So
our
you have
team.
the patent for it.
Right. So it is that. Okay. So when the vehicle is stopping, so you can see the speed profile. We can see. Because that is also for algorithm, that's an important input for queue detection. So and then the other vehicle, the the speed over time. So
So there's a delay delay between their actual stopping and.
I think it's just delay because it's just the interface, but it will be at an instant. Yeah. It will be like 1 millisecond.
So Ronnie, regarding your test bed, one thing that we're interested in is endpoints, right? Driver performance, driver behavior.
Right.
And do you have the capability for us to look at emissions and?
Yes, we can do that. But the emission, so we can give you the data. So how much delay, and then so we have to run another software. So use that data to find what was the emission. So we don't have any device to collect the emission data. So but we can input it into a program in a simulator to see like the moves or any other simulator to see how much emission that reduce. So, so but but we can do like so we can get the data from the field. So then we have to input into another simulation. Okay, let's run. So there was a delay, I think, because of this transfer, but it's but let's do one more run because you're getting used. I think they're having fun.
And yeah, they need practice because none of them have American driver's licenses.
But no, I have taking. So so before Mackenzie used to do it. So some people ask me why she's the fourth car. Actually, so she's the newest student. So as they progress, then they will just be a lead driver.
So, but do the cars respond themselves too? Or
we can make it. That's not hard. Like so, but right now they are not automatically stopping. It's manually, but that we can incorporate. So I think yes. Oh, so you see that collision?
They're all stopped now. So
Okay, stopped, and you see the speed profile. It's just flat.
Can I take a picture if you don't mind?
Yeah. I was so hopeful he's taking my picture, but can you move away? I just put my Tom Cruise glasses, but
There you go.
so they started. Okay. The speed profile is going. You see that instant?
Yeah.
So I think I just sending data because it has to be very, very quick,
Yes.
otherwise
Yes.
it will not work. So now our Q. So the Q warning was done. So
The Q warning, like the data that comes in is like very instant. So I'm just updating it. You could just see the flicker. It's
Oh yeah,
very,
so
very
it just
quick. I could slow it down and make it have a delay, but to be really
Visible.
instant. So
So it's just picking. So, but we can. This is for more for your display. But in the vehicle, it will be like immediate. But we just created this only for like today's demo. So for the visual stuff. So now we can go in the car and see what the onboard device that we have there. Let's go to the second car. Right now we are getting the warning. It is
Cell phone, okay.
we programmed it. We developed an app to get the message. But you'll have a device in the car. So.
Awesome.
We want to see you too. You're a connected driver, so no. You just open the lock. Are you scared? It's just locked. It's just locked. You just had it locked. Yeah. So in the car, so when the vehicle is stopped, so they are getting a warning in that the phone. So, but it's instant. We programmed the phone. We developed an app. So if any of you wants to ride it and see how the warning works instantly, please we can do one run with
So the third car is trying to crack into the system of the other
Right,
vehicle.
right. So when the cyber
You get the cyber
charge it,
attack,
put it- okay.
you know that's the vehicle. You can identify it.
Can I zoom into this?
And then this white stuff on here,
That's a GPS.
the GPS system. What is the price?
So you can watch
Right.
track and basically shut them down at some
later,
point.
right? So yeah, later. But we want to know more about it. Like
About
so,
the-
like when you identify some criminal, you try to know more
You
about
gotta
them.
have more
So
evidence to
whether
convict.
it is transmitting, like it's just like a criminal justice. So whether it's talking to other bad people. So we want to catch a lot of people at the same time. So is he alone or he has some help? So we want to identify that. Whether it's also bringing some other vehicles. So we want to more. So anyone interested in riding the connected car or?
Ronnie, question. Total cost of devices.
So, so the program will be free. So it will be $1,500.
$1,500, including the GPS.
Right. Yes. Yes. It comes together.
Okay.
Maximum 1,500 to 2,000.
And the price is dropping, right?
It's dropping because right now it's costing $100 to make, but they are charging more because of the development cost. They have to do a lot of research for the ESS benefit.
Okay.
But yeah, so the price is dropping.
Hey, Ronnie, you have 3 Nissans and a Ford.
Right.
What does that mean? You
So
got support from Nissan and Ford.
no, we are using rental cars.
Rented cars. So you can just add the technology to the
Any car, any car.
You wouldn't have to use it.
No.
It could be a shovel.
Right. Any. Right.
Does it need to be electric?
No. No.
In this case, you're not.
It can be. Yeah. Any vehicle. Just we just need this device and then the phone.
Where's it getting its power? From the car. So it plugs into the cigarette lighter. Yeah. Okay, great. Fascinating. So I'm telling you,
So that
we're going to have
yes, and it is so. Okay, were you there? No. Okay, so no, you can get like